Well, I'm glad you did it. It's kind of fun, right? Okay. But you could do that experiment at home too. All of these things, like instead of just like this starch and this iodine, you can actually buy all these things like at the pharmacy. And if you go to that website, IFL Science, it's like, okay, but without the stars, okay? It's actually, okay. So, but they have it there, and, or just Google like iodine clock reaction and go like, you know, supplies from pharmacy, and they'll give you the I could even just photocopy what I did today too. You know, you could do it at home. It'd be fun, right? Be like, hey, watch this. Okay. All right. So things. When dissolving occurs, these bonds break, and the ions or molecules of the solute become attracted to the solvent particles. Attracted to the solvent particles, which generally is water. Okay? So it's like the water kind of helps to break everything up. And since water is polar, right? It's polar, that it has both negative and positive ends. So all types of ions will have some form of attraction to water. So water's really good at breaking stuff up, right? Yeah, it is. Okay. So there's salt. Okay. There's where we see where we see our water, and then our little sodium ions. Okay, so the three processes involved in dissolving are, first, bonds broken between molecules or ions of solute. So bonds are broken. So that's like when we have salt and we need to break the bonds within Na and Cl. Okay? Now, this reaction, is it endothermic or exothermic? To break a bond, it's endo, to break the bond. When you guys were doing that other reaction, that hydrogen bonding one, you were forming bonds and it released energy. Remember that? Remember, because it heated up? So you were forming bonds and it released energy, which was exo. Breaking bonds requires energy. So just think about it if you forget, like, oh, how do I break something apart? Okay, I have to like pull, it's a lot of energy, okay? So energy needs to go into breaking the bond apart. Next thing, bonds are broken between molecules of solvent, which is endothermic again because it's breaking bonds. The last thing to happen is that bonds form between molecules or ions of solute and solvent. So like bonds would form between the sodium ions in the water, okay? This is always exothermic. Just like you guys saw in your hydrogen bonding lab, when you form bonds, it releases energy. Overall energy change in dissolving is equal to the sum of the three steps. This is the law of conservation of energy. If more energy is released
Is Hannah here today?
than is required,
I'm just going to take the table from the thing and I'll put it in the art room, okay? So you can start whenever you'd like.
the overall dissolving process is exothermic. So it's it's like you think about endothermic as like a minus, like if you're thinking in physics like about vectors, that would be the negative because it's required, it goes in, and then exothermic is positive. Okay? And then, so the next statement will be vice versa. If less energy is required, or sorry, less energy is released than is required. Sorry about that. Less energy is released than is required. The overall dissolving process is endothermic. When we dissolve compounds, I don't know if this is actually no. Okay, so turn over. Are we done on this side? No? No. Oh, okay. I don't think this is one of your bullets though. But when we dissolve compounds in water, water is not included as a reactant. So like when, say, we dissolve this, we didn't go like vitamin C plus iodine plus water. Because why? What can I do in my written reaction to imply that there was water? They would both be aqueous. So you don't need to write in plus water, you write in the state aqueous, right? And that implies that it is dissolved. It doesn't imply it, it states basically that it's dissolved in water, right? Okay. So water is not involved in the ion interaction, but it is not consumed, so it's not a reactant. Again, not a bullet. We symbolize compounds dissolving in water as writing aqueous as the state. Okay. Here's the word that I didn't write properly probably before. Dissociation. Did I spell it right? Sorry, thanks, yeah. So, this is a really, really important word. Highlight, star, circle, arrows, everything. This word dissociation is so important. Here's what it is. It occurs when ionic compounds, and only ionic compounds, okay? Only ionic compounds. When ionic compounds break apart into their ions, when they are dissolved in an aqueous solution. Very important definition.